Okay, so in this video, we will be discussing another property of Laplace transform. So the third property, which is called the second shifting property. Okay, so the second shifting property works if we have this form of the function. Okay, so that the the Laplace transform of g of t is equal to e raised to the negative as times f of s. Okay, so where f of s is the Laplace transform of f of t. Okay, and we can get f of t from here, g of t. So this only works if the function that we will be transforming is in this form. Okay, so the function g of t is equal to the split function of f of t minus a at t is greater than a and 0 if t is less than a. Okay, so all of the conditions here must be met, okay, so that we can apply this simple formula, okay, for the second shifting property. Okay, so say for example, so find the Laplace transform of the function g of t is equal to t minus 1 squared if t is greater than 1 and then 0 if t is less than 1. Okay, so as you can see, it is similar in form here. So we have t minus a here, so our a is equal to 1, right? So t is greater than 1 and t is less than 1 for 0. Okay, so first, so we will look at here. So this is f of t minus a. Okay, so f of t minus a, or f of t minus 1. Okay, so since our a is equal to 1, so the function of t minus 1 is t minus 1 squared. Okay, so therefore f of t is simply equal to t squared, right? Okay, and we need to get the Laplace transform of f of t. So the Laplace transform of f of t is equal to, so formula for this, so we have 2 factorial over s raised to 2 plus 1. So 2 factorial over s raised to 2 plus 1. Okay, so this is equal to 2 over s cubed. Okay, so this is now our f of s. Okay, so to get the Laplace transform of g of t, all we need to do is multiply this Laplace transform with e raised to the negative as, for which our a is equal to 1. So therefore, the Laplace transform of g of t is equal to e raised to negative as, so negative 1 times s multiplied by f of s. Okay, the Laplace transform is 2 over s cubed. Okay, so our Laplace transform simply is, we have 2 e raised to negative s over s cubed. Okay, so that is already the Laplace transform of this function. Oh, sorry, this function. Okay, so that's yeah, so that's really very simple. Okay, so all you need to do is memorize this formula. Okay, you also have to memorize this form, because you can only use this if the function is in this form. Okay, okay, so another example. So find the Laplace transform of the function. We have a split function g of t, for which the value of the function is sine of t minus pi over 3 if t is greater than pi over 3, and it is 0 if t is less than pi over 3. Okay, so first identify So our a obviously is pi over 3. Okay, then our f of t minus a, so f of t minus a, which is pi over 3, is equal to sine of t minus pi over 3. Okay, so since we are only looking for f of t, then f of t is equal to, replace t minus pi over 3 with t only. So you have sine of t. Okay, and then the Laplace transform of f of t is equal to, from the formula, the Laplace transform of sine of t. So recall, the Laplace transform of sine of omega t is equal to omega over s squared plus omega squared. Okay, so our omega here obviously is 1, so therefore its Laplace transform is 1 over s squared plus 1 squared. Okay, or 1 over s squared plus 1. So this is now our f of s. Okay, so from the formula of the second shifting property, so the Laplace transform of g of t is equal to e raised to negative as. So our a is pi over 3. Okay, times s multiplied by f of s, so which is 1 over s squared plus 1. Okay, so therefore the Laplace transform is equal to, simplifying this, is equal to, so that is equal to e raised to negative pi s over 3 over s squared plus 1. Okay, so it's very simple. Okay, but again, don't be, you should always remember that the function must follow this condition. Okay, so if not, then this formula cannot be applied. Okay, so good luck.